Hello everyone, this is my next video lecture regarding class 11th chapter Some Basic Concepts of Chemistry, and in this lecture we will discuss the law of chemical combinations. There are total 5 types of law of combinations: the law of conservation of a mass, the law of constant proportion, law of multiple proportion, and law of reciprocal proportion, and Gay-Lussac's law of combining volumes. So in this lecture we will discuss what is law of chemical combination. So firstly we will discuss the law of chemical combination. As we know that the smallest portion of matter is an atom, and the atoms of same or different elements combine to form molecule. The chemical reaction involve atoms and molecules, and on the basis of it we will study the chemical combination. So in short, I can say that as we know the atoms combine to form compound or a molecules. So basically we will discuss the laws on which laws that combination will happen or occur. So now, as we know, there are total 5 different type of laws of chemical reactions or chemical combination. So as these are given as law of conservation of a mass, law of constant composition or definite proportion, law of multiple proportion, law of reciprocal proportion, and Gay-Lussac's law of combining volumes. So we can say that chemistry is the study of transition of matter from one form to other. So these transformations often occur as a result of the combination of two different types of matter. The combination of different elements to form compounds is governed by certain basic rules, and these rules are referred to the law of chemical combination. So as I said you earlier that there are total 5 basic rules which will tell us you the law of chemical combination. So in this lecture we will discuss first 3 laws: the law of conservation of a mass, the law of constant proportion, the law of multiple proportions. So moving to next, our first law of conservation of mass. So this law deals with the relation between the mass of the reactants and products in the physical changes as well as in the chemical reactions. And we know what are physical changes and what are chemical reactions in the earlier videos. So the law was given by the Antoine Lavoisier. According to him, in any physical change and a chemical reaction, the total mass of products is same as the total mass of the reactants, or we can say that according to this law, mass is neither created nor destroyed during chemical combination of a metal. So sum of masses of reactants is always equal to the mass of the product. For example, burning of carbon. So carbon combines with oxygen during burning and it will form carbon dioxide. So for example, we can say that if one carbon combines with O2, that is oxygen from air, it will form CO2. So mass of carbon is 12. As we know that I shared a video with you that contains atomic number from 1 to 30 and contains atomic masses also. So you can learn that atomic masses from that video of mine. And the mass for oxygen, it will be 16 for one atom. As we have a 2, so it will be multiplied with 2. So 12 plus 32, it will be your 44. We can say that in left hand side there is 24, and in right hand side if you calculate the mass of carbon and oxygen, it will also be 44. So we can say that in simple words that this law states that matter can neither be created nor be destroyed, or we can say the total mass, that is the sum of the mass of the reacting mixtures and the product formed, remains constant. Antoine Lavoisier gave this law in the year 1789 based on the data he obtained after carefully studying the many combustion reactions. So this law is also named as law of indestructibility because the things are created remains as such after the transformation. The amount or the quantity remains the same. So this is Antoine Lavoisier, and he said that a matter can neither be created nor be destroyed in a chemical reaction. So total mass of the reactant is equal to the total mass of the products formed. So this is what happening here. Another example, for example, oxygen combines with hydrogen, it will form water. So on the left hand side we have a raw material known as a reactants, and on the right hand side we have a product. As you know, you have studied this in 10th class also. So oxygen when combines with hydrogen it forms water. So here the mass of oxygen will taken as a 40 grams, so hydrogen we take is 5 gram. So if we combine these both we get 45 gram. So the same will there, that after combining we get a water and its quantity is 45 grams. So it represents that the amount of the reactants combined is equal to the amount of the product formed. So now next is verification of the law of conservation of mass. This law is verified by the Landolt by using the H-shaped tube. This is the H-shaped tube, English alphabet H. It represents like a H-shaped tube. This H-shaped tube is used by Landolt to verify the Antony's law. He used this tube. He contained NaCl, that is sodium chloride, in a one limb of a tube and silver nitrate in the other limb of a tube, and then he weighed the tube and he checked the weight of the tube, and after some time he shake the tube in order so that these two mixtures get intermixed with each other, and the chemical reaction between the two salts results in a white precipitate. And after that precipitation he also weighed the tube and he checked that weight before the reaction or before the mixing is equals to the weight after the mixing. So what happens here is basically the precipitation of silver chloride. We know we have AgNO3, we have NaCl. So AgNO3 with NaCl will form AgCl plus NaNO3. This reaction you also studied in your 10th class, I think in first chapter, that is your chemical reaction. So what is basically happening, as I said, that he checked the weight after the mixing also, and he checked that before the mixing and after the mixing the mass is same. So this justifies the laws of conservation of mass. So in nutshell we can say that in a chemical reaction the reactant species only exchange partners to form new species known as the product. So this is what happening here, that silver Ag just exchanges its partner with NaCl, basically AgNO3. This silver Ag exchange its partner with the sodium by taking the chlorine with itself and removing NaNO3 will form, and we can say that AgNO3 exchange its partners with the sodium chloride and form AgCl and NaNO3, and this downward arrow represents the formation of precipitate. Hope you guys understand. So now moving to numeric portion of this law. First law, the weight of sodium chloride is decomposed by 4.9 gram of sulfuric acid if 6 gram of sodium hydrogen sulfate and 1.825 gram of hydrogen chloride are produced in the same reaction. So we have to check the weight of the sodium chloride is decomposed, how much it is decomposed by the sulfuric acid. So we know that given is NaCl and H2SO4, these are the reactants and these two are the product, and after the completion of the reaction we get NaCl plus H2SO4, that is your sulfuric acid, combines to form sodium hydrogen sulfate and hydrogen chloride. We know the amount of sodium hydrogen sulfate, we know the amount of hydrogen chloride, we know the amount of sulfuric acid. The thing we want to know is the weight of the sodium chloride. So we will use this law, as we know that here the law of conservation of mass is eligible or applicable. So by using that law we can say that we can take it as x gram which we want to find, and then it will be 4.9, and this by simple addition we get 7.825, and this my plus 4.9 will go there and be minus 4.9, and we get the result 2.925 grams. So this means that the NaCl decomposed by 4.9 gram of sulfuric acid to form the sodium hydrogen sulfate and hydrogen chloride. So I will give these two questions to you. Try to solve these questions and hopefully you will get the result. Now moving to next law, that is law of definite proportion or constant composition. As the name indicates, definite means fixed, constant means fixed. So according to this law states that compound is always composed of the same elements in the same proportions by the mass, no matter how large or small the sample is. It doesn't matter the compound is present in a large quantity or in a small quantity, but its elements remain in a fixed proportion by the mass. This is given by this law. So the mass of a compound is equal to the sum of the masses of the elements that make up the compound. So what this law is basically, this law deals with the composition of various elements present in a compound. Therefore, according to this law, a pure chemical compound always consists of the same elements combined together in a fixed or definite or constant proportion by weight. This we also studied in the lecture where we discuss compounds. So now we will illustrate the law of definite proportion with the help of example of carbon dioxide. So what we can take, we can say that there are number of ways by which the carbon dioxide can form. But firstly I will tell you one more thing, that always write carbon dioxide where carbon and oxygen must be of the same size. If you write like this, that carbon is of bigger size and oxygen of smaller size, then it will not be representation of carbon monoxide, it will represent the cobalt element of a D block that we have studied in atomic number from 21 to 30. So make sure don't write like this, and always write, if you are writing carbon dioxide or carbon monoxide, so write like this. This is the right way to write or to represent. But this C and small o, this is not the right way, this is the wrong way. You don't use this notation to represent the carbon and oxygen, but you have to use this notation to represent the cobalt. So use this CO to write the carbon monoxide and carbon dioxide. So now we will move into this law back. We will discuss the formation of carbon dioxide, how this carbon dioxide formation will take place. So this is done first by the burning of coke in air. So we have a coke, it combines with oxygen from air and will form carbon dioxide by heating. This heating and this triangle represents the sign of heating. You all studied in your 10th standard also, so you know this very well. Okay, this is a triangle. Basically this is the sign of a triangle. So moving to next, the second, here we can say that carbon dioxide formation take place. Second example, by the decomposition of limestone on heating. So when we heat this, so by decomposition of limestone, when we heat calcium carbonate, that is limestone, then we get calcium oxide and carbon dioxide. This is a symbol of heat. This triangle represents the symbol of heat. So in this example, carbon dioxide formation take place. Another example is, that is sodium carbonate or washing soda. This is also used when reacted with HCl, it will form carbon dioxide. This is another way to form the carbon dioxide. So in all these three examples we can say that the formation of carbon dioxide is there and the ratio remains the same. As you see, one carbon and two oxygen there. So mass of carbon is 12, the mass of one oxygen 16, and as it is 2, so multiply by 2, we get 32. So to simplify this, we get 12 in the form 4 into 3, and same with here we can have this. So by cutting this 4 with 4, we left with 3 ratio 8. This proportion, this ratio we also discussed in the compound lecture for the representing the fixed ratio. So therefore the ratio of carbon dioxide is fixed in all the above reactions. So this justify that the law of constant proportion or constant composition is there. So basically, what is the law of definite proportion? In short, we can say that a chemical compound always contains its components elements in a fixed ratio by mass, and it does not depend on its source and method of preparation, which I am trying to solve here and tell you here that the source or the method of preparation doesn't matter. Always we get the compound in a fixed ratio by mass. So this is a good example. We have discussed that we get carbon dioxide from three other means, but the product is in the same ratio. So Joseph Frost derived this law, gave this law, and said that the proportion of the elements by weight in a given compound will always remain exactly the same, or we can say that irrespective of its source, origin, or its quantity, the percent composition of elements by weight in a given compound will always remain the same. So we can say that the law of constant composition is a compound consists of elements having a present in a definite proportion by weight, or a compound consists of elements which are present in a definite proportion by weight. So moving to numeric portion of this law also, we are discussing the first law, first numerical, that is a copper sulfate crystal contain 2.45% copper and 36.07% water. If the law of constant composition is true, calculate the weight of copper required to obtain the 40 gram of crystalline copper sulfate. So we have given with percentage of copper, percentage of water. So by the combining we get, as we know that crystalline copper sulfate contains water, sulfate and copper. We know the copper, we know the water, we want to know about the sulfate ions. So what we will say, we know that the sum of everything will result into 100%. So percentage of sulfate we can check it by 100 minus the percentage of copper and water, so we get 38.48%. So now we want to check for the 100 gram of copper sulfate contains, as we know that it contains copper of 25.45 gram. We want to know the amount. So therefore 1 gram of copper crystal contains copper of 25.45. This 100 go there. The simple mathematics you have studied in your 6th or 7th standard also. So we want to calculate for the 40 gram of crystalline copper. We want to check the weight of copper for 40 gram of crystalline copper. So what we will do therefore the 40 gram of copper sulfate contains 25.45 divided by 100 multiplied by 40. So this we will get the 10.18 gram. So in this numerical, if you don't do this term, this is also sufficient. But I told you this because I want show you that always the sum of anything, the total product is always 100%, because probability can never be more than 100%. This is the second example where copper oxide was prepared by the different method. In first case 1.7 gram of metal gave 2.19 gram of metal oxide. This is what 1.75 will give 2.19 gram, and in the second case 1.14 gram will give you 1.43 gram. So we have to just show that the data illustrate the law of constant composition. So what we will do, we will check the percentage of metal in metal oxide. So we know the mass of copper, that is 1.75 gram, we know, and we know the mass of copper oxide here, that is your 2.19, and we will get the percentage, so it multiply by 100, we get 79.9%. Same we will do this here, and we will check that the percentage will remain the same or we get the same. So this justify that this law is applicable. I will give you this work by you try to solve this question, and I will give this answer with you, but I will not discuss this answer with you. I know you understand very well. So check this answer after doing it yourself. After that, check this answer with your answer. So the law of multiple proportion, this is the third law, the last topic of today's video lecture. So according to this law, when the same two elements combine to form more than one compound, the ratio of the mass of the one element in the first compound to the mass in the second compound can always be expressed as a ratio of a whole number. So example is, we know that carbon combines with oxygen to form carbon dioxide or carbon monoxide. So mass of carbon is fixed, mass of oxygen we know, here is 16, here is 32, as 2 oxygen as 1 oxygen. So the ratio is, here there will be a simple thing, the ratio of oxygen in CO2 to 1. Here the 1 oxygen is there and here 2 oxygen are there. So the ratio for the as the carbon weight is fixed, so we get a ratio of 2:1 by simply we can say dividing the 32 ratio 16. So we will get 2:1. Hope you guys understand this. So the law of multiple proportion, this law is given by Dalton. According to it, if two elements combine to form two or more compound, the weight of one of the element which combine with the fixed weight of the other in these compound bear a simple whole number ratio by weight. So to illustrate this law, we will use the example of compound of nitrogen and oxygen. When two elements of nitrogen and oxygen combine, they will form 5 different oxides known as the oxides of nitrogen, that is the nitrous oxide, nitric oxide, nitrogen trioxide, nitrogen tetraoxide and nitrogen pentoxide. So we will fix one element pass by 14 parts weight of nitrogen is, we will take it fixed, and we calculate the weight of oxygen by combining with the 14 parts by weight of nitrogen in these oxides. As we know that the nitrogen is having a weight 14 and oxygen with the 16, so we try to fix the mass of the element which is of lesser than other. So we fix the parts by weight of nitrogen here, and we have these 5 oxides, and then mass of the parts by weight of nitrogen, here 2 nitrogen, so it will be 28, here 1 nitrogen, it will be 14, here 2 nitrogen 28, Same with here 228, 228. So here with oxygen, one oxygen 16, another one oxygen 16. For three oxygen we have a 48, and that is 16 multiplied by 3. Here 16 multiplied by 4 we have a 64, and here 16 multiplied by 5 we have a 80. Why we are multiplying with 60? Because the mass of one oxygen is 16. We are having here 5, so we multiply with 5. Now calculate the weight of oxygen which combined with the fixed part of the nitrogen. So we will simply do, as we know how we will get 14 out of 28 by simply dividing it with 2. The same thing we will do with here. As we divide this with 2 we get 14. So the 14 is fixed. So what we are going to do with here, will same operation will apply here. So we are going to divide with 2, same with here, so we get 8. Here the 14 is remain same, so 16 will remain as such. As 28 we have to divide with 2, the same with here. So when we divide 48 by 2 we get 24. Why? Same with here we get 32, and same with here we get a 40. So we get oxygen by fixing the nitrogen by 14 parts in 8, 16, 24, 32 and 40. So what we will see, the ratio between the weight of the oxygen in fixing the nitrogen, we get 8, 16, 24, 32 and 40, and these all are the table of 8, and we can say after cutting we get 2, 3, 4, 5. So these ratio come out to be a simple whole number, and whole number, I know you know that because you are grown up students even in class 11th. So whole number is simple number which is not present in a fraction. So therefore the law is verified. So I can say that in nutshell this law states that if two elements combine to form more than one compound, the masses of these elements in the reaction are in the ratio of the small whole number, and this law is given by Dalton in 1803. So try to do this question with yourself. I know this is simple, we discussed earlier also. Try to do this. So the numerical is here that carbon and hydrogen combine to form three compounds A, B and C, and the percentage of hydrogen in these compounds are 25, 14.3 and 7.7 respectively. Show that this data illustrates the law of multiple proportion. So what we will do, we have to fix one thing. We fix here hydrogen because hydrogen is having a one weight from this carbon and hydrogen. It is smaller, so we fix it as a hydrogen. So in a compound A we get weight of hydrogen that is 25 gram, and the leftover carbon will be 75. So we can say 25 gram of hydrogen combined with 75 gram of carbon. So 1 gram of hydrogen combined with 75 upon 25, so it will be 3. Same for the compound 2. We know hydrogen is 14.3, the leftover will be your carbon, and we can say that if 14.3 gram of hydrogen combined with 85.7 gram of carbon, so 1 gram will having a 85.7 divided by 14.3 and then multiply with this amount, and we get 85.7 divided by 14.3 and we get 5.9, and which is 6 gram. So in third compound C, we know that we are having a 7.7 hydrogen and the leftover will be your carbon, and after dividing it with that we get 11.9998 and we left with round off with the 12 grams. So we can say that compound A, B and C we get 3, 6 and 12. So this is a multiple of 3. We get 1, 2 or 4. So all the things are of the whole number. So this law is proved here. This question I will give you as a your work. So try to do this simple question. 2.66 gram of chlorine of a metal when treated with silver nitrate solution gave 2.87 gram of silver chloride. 3.37 gram of another chloride of a sample metal gave 5.74 gram of silver chloride when treated with silver nitrate solution. Show that this result illustrates the law of multiple proportion. So this is the way you can do. Firstly write the reaction AgNO3 with metal chloride and you get metal nitrate and AgCl. So molecular mass of silver chloride, we know mass of silver is 108, mass of chlorine is 35.5, we get 143.5. In the first case we have 143.5 gram of silver chloride contains chlorine 35.5. 1 gram will have this divided by this, and 2.8 will have this divided by this multiplied by this 0.71 gram. So we can say chlorine is present in silver has been obtained from the metal chloride, therefore mass of metal in the sample is 2.66 minus 0.71. So we get the mass of the metal here. In a second we will do the same thing and we will get 1.42 gram and 1.9. So metal remains fixed in both the cases. So we have to check the weight of the chlorine. So we can check 0.71 ratio 1.42 and we get with 1.2. So therefore the law is verified here also. Thank you. Hope you guys like this video.